Hello everyone, welcome back to the channel. And if this is your first time to the channel, welcome to the channel. We're very happy to have you here, and we look forward to seeing you in future videos. Today we're going to talk about pointers. We're going to talk about 4 specific questions. Why don't you see them in high-level languages? What they actually are, why you need them, and pointer arithmetic. So, and actually, before I forget, if you do enjoy this type of content where you care about this miscellaneous trivia, I guess you could say, of making your life easier when it comes to programming, understanding the inner workings of programming languages, please do hit that like button. It lets me know that this type of content is liked by people and to make more of it. And if you like the videos in general, please do consider subscribing. It helps get the videos out to a larger audience. All right, so now that all the fun little marketing stuff's out of the way, let's actually talk about the subject at hand, pointers. So before we can talk about pointers, the thing we need to discuss is memory. Inside your computer, there is memory in the RAM. And each memory bank, or I should say locker, because we're using lockers as this example, you can see by this image I should say, has an address associated with it, which is essentially a locker number. Ironically, these lockers don't have numbers. Looks like they have barcodes, but not numbers. Ironic, but inside of the memory, I can assure you that each locker or each byte does have a memory address associated with it. So, in high-level languages, why don't you see pointers? Well, it's because you don't really have to worry about the memory. When you say, I want a variable that holds a number, while the language is running, it will actually just say, you want a number? Okay, here you go. You can work with a number. Behind the scenes, it will allocate the memory for you. When you're done with it, the garbage collector will come and get rid of that memory for you or free it up. It will deallocate it. So that's why you don't see it in high-level languages. However, if you're working with C++ or C or other lower-level languages, you need to work with memory. So your first usual hello world example, you see things where they might work with an integer and they just call it, I don't know, int my number, and you'll do something like this. You'll set it to the number 100, and that works fine. You don't have to work really with memory either. So why is that? Well, that has to do with a thing called the stack. And if we go back to our locker analogy, actually, we'll come back to the lockers in a split second. A stack is like this, a stack of plates. So the reason it's called a stack is it has to do with the way that the memory is allocated and deallocated. If you happen, let's say you were here at this blue plate and you needed 1, 2, 3, 4, 5, really strange number for programming, but let's say you need 5 bytes of memory, it would allocate these 5 bytes. And when it frees that memory, it will take these 5 bytes, or 5 plates in this example, and it will throw them away. And then you're back to this blue plate. Now you might be wondering why that is, and that has to do with the way the memory actually works. Using our lockers as an example, let's say that your program is using 3 bytes of memory and you say, I need those 5 more bytes. Well, it will go 1, 2, 3, 4, 5, and it will say these are the 5 bytes of memory that you want to work with. Actually, I take that back. Instead of 5 bytes, let's use 4 because on our code example, we're using an integer. And let's relate this more to programming code rather than eating, even though I would say coding and eating are probably equally as important. We will stick to coding. So we had these 3 bytes of memory allocated, and then we wanted 4 more. So for our integer that we just set to the number 100, it will store that 100 across these 4 lockers. Because it's an integer, if you know all the ins and outs, it's technically only going to be storing it in 1 locker, but that's just semantics for us. In this case, we're not going to worry about that. The point being, when we're done with our lockers, so let's say we have our int main function here, and when we hit this end curly brace, we are done with this memory. We no longer need this number. What it will end up doing is these 4 lockers are no longer needed, so it will free them up. And we will only have these 3 lockers allocated in memory. So again, that's our plate example of what's currently allocated in memory. Basically, the last thing you allocated is the first thing to go away. Okay, that's the moral of the story. Now, besides the stack, there's a thing called the heap. In C, it's called the free store in C++, but essentially it means the same thing. And that is when you say, I need an integer off of the heap. And the OS will say, okay, I allocated 4 bytes of memory for you, because that's how big an integer generally is. And the location of where it begins is at, let's say, locker 1000. And we'll say that this yellowish green locker is where that locker 1000 happens to be. So that number that you have to work with then is 1000, 1001, 1002, 1003. And as an FYI, if you access 1004, you do not have access to it, and that's called an access violation. So if you've seen that in your programming journey, that's why. In Linux, when you compile with GCC, it's usually called like a segment fault. Anyway, point being, if you've seen that error, that's why. So now the question is, pointers, why do we need them? Well, the OS told us that we're working with address 1000. And we might have gotten that by, here's the fact that it's a pointer. We did something like mallocate, and we said size of an integer. All right, so it will have acquired our 4 bytes for us, because I'm assuming in this case an integer is 4 bytes, but in case it's not, whatever the size of it is, that's how much we allocated. And it will return the address. So what we'll say is that it gave us the address 1000 for this example. That's the actual number that is stored into our pointer, is this 1000. Now, you might be wondering, why are we going through all these hoops? And the reason is, when you are done with this memory, you need to free it. If you don't free it, it's called a memory leak. And the reason it's called a memory leak is because if you look at your processes, it'll say, well, this memory is used, this memory is used, this is used, this is used, and you can't actually access it anymore because you don't remember off the top of your head. You didn't write down on paper where all these memory addresses were stored. So it's like the memory is leaking out of the computer. You just eventually run out of memory. So we've discussed a couple different errors you might see and why they're named what they are. That's always fun. Anyway, though, so when we talked about the OS, when we did mallocate, we were saying we want this block of 4 lockers. And then when we call free, we tell the OS and we say, hey, by the way, I'm done with this block. And it will go, okay, you're done with it. You can no longer access it. If you access it after you've freed it, you will get your access violation yet again. Also, you cannot do a thing called a double free, which is where you free it and then tell the OS, hey, I'm done with that block. It will go, you didn't have control of that block, and you are freeing it again. And it will go, okay, I don't know what you're doing anymore, and I don't think you know what you're doing, so I'm just going to end the program for you and give you an error. Isn't it nice that computers automatically assume that you don't know what you're doing? Especially considering the fact that they do exactly what you tell them to do, so if anyone doesn't know what they're doing, it's the computer. All right, enough of that. So why do we need pointers? Well, as I was saying, on the heap, we're allocating a block of memory, and then we're using it, and then we're freeing it. So we're essentially storing 2 different things. We're storing the actual memory address, because we need to know that so we can free it later on, and we're storing the thing we care about. So when you actually want to work with this then, if you were to do my number equals, and then you were to just put some other number in here, let's say you care about that number for whatever reason, this is now the memory address that it is pointing to. Haha, there's where pointer comes from. It's pointing to this memory address, which in our little example could be, I don't know, this locker down over here. That's not the locker we want to work with, and the minute we try to use it, the OS is probably going to kick us out and say our program is accessing stuff we shouldn't be. All right, so how do we actually store this random number that I just generated into the actual locker itself, into the actual little greenish locker bank that we have reserved? It's called dereferencing when we want to work with that. So what we actually would do is we would put this little asterisk in front of our number, and then we can store whatever this is. Me randomly typing that again is pretty rare, so we'll copy paste it. I'm going to get rid of this line of code because we already discussed that's an error, and this is an error too because we can't free our memory before we use it. Now we're at the point that we have valid code. What we have done is we've said we want a block of memory that's the size of an integer. The OS is returning in our example the memory address of 1000, and we're storing that memory address so later on we are able to free it. Now we actually want to use that memory though and store something in it, and that's what this little ampersand does. All right, so we've discussed what they are and why we need them. Now let's talk briefly about pointer arithmetic. Pointer arithmetic is in the case of, let's say this is a character, and we want to allocate a bunch of characters. Let's say 4 of them. Why not? So what we'll do is size of character is going to be the size of 1 byte, and we say we want 4 of them. You might be wondering, well, why would you want 4 characters? And obviously that is for a string. Now I'm not going to go through all the fun logic that it takes to actually save strings in memory in regular straight up C here, but let's pretend that you actually can do it. Oh, don't forget the asterisk. Let's say you actually could do it this way. Let's see, there's 4 characters. This is not valid, and you can don't do it this way. This is not good, but it sort of illustrates the point here of, if we go back to our memory address, that the A would be stored here, the B would be stored here, or sorry, the S would be stored here, the D and the F, because we did A, S, D, F, the first 4 keys on the home row. So let's say we want to actually access the letter S, which we know is the second character. What we would do then is pointer arithmetic, where we would say my number plus 1. And this would be the letter S. So we're taking our address 1000, we're adding 1 to it, which in memory, going back to our locker example, is this locker. And then we are saying pull the actual thing out of the locker, and that's what the little asterisk is doing here. So we could do something like this if we want to change its value to something like the letter Q. This would allow us to do that. We could store Q into that locker for us. If we want to take that S back out and store it in a regular character on the stack, we could do something like this. And now after this, my char would equal the letter S. So we've talked about pointer arithmetic. Now there are some dangers with it, and that is going beyond what you actually have allocated and gives you an access violation like we talked about before. If we tried to access my number plus 4, that's called an off by 1 error, by the way. What it would do is it would take us in locker 1004, and as you recall, when we counted this out before, this is 1000, 1001, 1002, 1003. So 1004 we don't have access to. It's called an off by 1 error. All right, so in this video we have discussed why you don't see pointers in high-level languages, what they are, why we need them, and pointer arithmetic. So we look forward to seeing you in the next video, and until then, and keep programming and keep learning different things, because programming is always fun.